Hello my dear students. So as we have studied in the last lecture about the partial balancing, which is primary balancing of two cylinder locomotives, I have given you one numerical to solve with the help of dynamic balancing technique, which I have already explained you in previous lectures. So how we can solve, I will see here that you have to, first of all, with the help of configuration diagram, you have to draw the table or prepare a table for the dynamic balancing problem, as it is mentioned in the picture, that you have to mention the planes, then masses, which is MA and MD, which are unknown masses, and the two masses are known. Then the radius of rotation of all the respective masses at the different planes, and then you have to calculate the centrifugal forces, which is irrespective of your omega square. Means omega square is common, which is radius of angular speed of all the planes are same, so we are skipping that angular velocity here. And you have to take the reference plane. Reference plane should always consist of maximum number of unknowns. So in these two planes A and D, there are two unknowns. So for the sake of the calculation, I have taken reference plane at A, which is your plane number 1. So the distance from the reference plane will be 0, and the product of force and L, which is called as moment, so that will become as 0, and rest you will calculate. So now you are ready with only one unknown, so you have to draw the moment polygon and calculate the value of MD and theta D. So if you will get the value of MD and theta D here, then put it here in the column of forces. Then you can calculate the value of MA and theta A, means magnitude of mass A and magnitude of angular position of theta A. So this you can solve with the help of this technique. So these are the answers which you can cross verify if you have practiced theta D and MD, and this is the answer of MA and theta A. So these are the four unknowns you have to calculate with the help of the dynamic balancing problem to solve this problem of your two cylinder locomotive. Okay, hope you understand, and you can practice many questions with the help of your SS Ratan book and RS Khurmi book. Now this I have already explained, that hammer blow should always be less than the per wheel static load. And if you want to calculate the value of limiting value of speed, means at which speed your locomotive should run, so you can calculate omega is equals to under root P by BB, where P is your per wheel static load. So this will give you the limiting value of speed. Sometime it has been asked in the objective question paper that you have to calculate the limiting speed. There you can directly use this formula. If you want to practice the questions, then you can also note down this problem for your home assignment. You have to calculate the values of the unknown masses. This is the problem, that rotating balance per cylinder is given 160, reciprocating is given 180, then the mass of connecting rod is given. Then this is the whole problem. This is the center line of locomotive, and you have to find the balance masses along with their angular position, means MA, theta A, MD and theta D. Means this is the same problem of your dynamic balancing. You have to solve it by dynamic balancing graphical method of balancing and get the answers. Now I am moving towards the calculation of your secondary balancing reciprocating masses, as we have explained it very beautifully, that how you can use secondary balancing of reciprocating masses. This is the second part of your reciprocating unbalanced forces. As you all know that secondary unbalanced force can be written as mr omega square cos 2 theta by n, which you have already seen in the reciprocating masses unbalancing. So what is the analogy between the primary and secondary forces? That we will see that the mass m and mass m will be same in both the forces, either primary or secondary. But r, this radius of rotation will change to r by 4n here, and this omega will change to 2 omega here, and this angular velocity theta in the primary and 2 theta will be there in the secondary. So whenever you will draw the table, that there will be a change in this radius of rotation, and remaining all things will be same for the calculation part. And in your configuration diagram in primary balancing, these two cranks, means the plane B and plane C are at 90 degree, means two cranks of two respective cylinders are at 90 degree, while in secondary forces calculation it is at 180, means this is 2 theta. So after that you have to draw the moment and force polygon with the above table and secondary configuration diagram, and balance masses for the secondary forces can be calculated with the help of this technique. Now this is the example of 4-cylinder inline engine. Right here I have skipped to write 1, 2, 3, 4. All are at a distance of 90 degree. This is the primary configuration diagram. If we want to convert it into secondary, then it will be like 1, 2 at 180 degree, 3 and 4, this is at 180 degree. Means all the respective angles of the primary configuration diagram will be multiplied by 2, then it will become the secondary configuration diagram. Okay, so this way you can calculate. This is the comparative chart of your primary balancing, secondary balancing. As you know that primary balancing are mr omega square cos theta, while secondary balancing are m into r by 4 and 2 omega square into cos 2 theta. Table for the force and moment polygon will be same as you used to draw in the dynamic balancing, but table only changes at r changes to r by 4, and remaining all things will be same in the secondary balancing, and your configuration diagram will be changed from 90 degree to 180 degree, means from theta to 2 theta. So this is the change you will get in primary balancing and secondary balancing. Note it down, this will be very helpful for your objective questions. Now the role of firing order in multi-cylinder engines in balancing. What is the role of firing order? That I will see that if there are total 4 cylinders, then your primary configuration diagram will be like this. Your secondary configuration diagram will be like this, as I have explained above. So what will be the value of primary forces? Primary forces will be balanced like this, means no balancing masses are required to balance primary forces in the primary configuration diagram. Similarly, there is no secondary in the secondary force polygon, no balance mass are required because this is already balanced. Now moving towards the primary moment polygon, then you will see this is some balance masses are required to balance this primary moment polygon, and in the similarly in the secondary moment polygon, balance masses required to balance the secondary moment also. Okay, so here you require secondary masses. So in this way I can say that the best firing order can reduce the requirement of balance mass, means this way you can reduce the balance mass requirement if you are using balancing order very judiciously. So this is the way, and this kind of balancing is called as passive balancing. If somewhere they have asked what is the passive balancing, then you can say balancing of engine by firing order is called as balancing of passive balancing. So 4-cylinder inline engines are primary and secondary forces are balanced, while moments are either primary or secondary are not balanced. So 4-cylinder cannot be completely balanced by firing order, while 6-cylinder inline engines are completely balanced by firing order. This you have to note it down, that 6-cylinder engines are completely balanced by firing order. You have if you want to recall the firing order sequence, then you can note it down here. For the 4-cylinder it is 1 3 4 2, and the firing order for the 6-cylinder is 1 6 3 5 4 2 at 60 degree cranks. Means first cylinder number 1 will fire, then 6, then 3, 5, then 4, then 2. Similarly in the 4-cylinder, first cylinder number 1 will fire, then 3, then 4, then 2. So this is the firing order for the 4-cylinder and 6-cylinder engines. So I am stopping here as of now. We will see what is the direct and reverse crank method in the next lectures, which will be the concluding lecture of balancing. Hope you have understand all the basic concepts of primary and secondary balancing, which is a part of reciprocating unbalancing, and you have understand the rotating balancing of unbalanced masses, which is static and dynamic balancing. Keep practicing. Go to your textbook and find out some questions related to your numericals in your previous year question papers of university exams and some objectives of GATE and IAS, and do practice. Then only you will understand what is the philosophy behind balancing of locomotives or balancing of unbalanced masses. Thank you so much. Keep visiting our GC Banswara YouTube channel for more update. We will update day by day of with the various different topics of all branches of engineering. Thank you so much. GC Banswara YouTube channel will showcase you all the videos of different subjects of computer science engineering, mechanical engineering, applied science, electrical engineering and civil engineering. So you can visit our YouTube channel and see what are the different topics has been elaborated or explained by various experts of the domains. You will be enlightened by their knowledge. Hope you will watch the channel and subscribe GC Banswara YouTube channel. Thank you so much. Keep visiting.